Okay, so today we're going to be covering tests. The last office hours we were covering the controller, a little bit of the controller. We did a little bit of the pizza service here, but the main emphasis that we had was on Lombok and the pizza repository. So what we're going to do is, you guys had asked for tests. So what we're going to do is we're going to try to figure out how to write tests for all of these components. Okay. But basically a test is, when you think about a test, you always test, no matter what. Anytime you write code, you're testing it. Okay. So the benefit that comes from writing the test is that it is now automated. And so for instance, and it saves you time. So basically, if you have to go and you have to write a code, right? Or you have to, let's say you're making a game, right? And the game is you shoot a zombie in the head and you get like 200 extra points. So that's your feature. You go in and then to test it, you actually have to go in and shoot the zombie in the head and get the extra points, right? But then the next thing is whenever you pick up a gas tank and you drink it, you die or something stupid like that, right? So then when you go back to test it, how do you know that that gasoline code did not break your headshot code, right? So to test it, you got to go back, you test the gasoline, you drink it, then you die, and then you go back and make sure that you can shoot the zombie in the head and get the extra bonus points. And then another feature that you want to add would be like you can take a alcohol bottle and you can actually light it to make a Molotov cocktail. Thank you. So it's a Molotov cocktail. So okay, now you got to go back and you write that feature, right? But then when you test it, you light it on fire and then you throw it and then you make sure that the flame can spread on the building, right? So like you are going and you're already testing. You're just doing it manually. And the problem with that though is, well, how do you know your Molotov cocktail code didn't screw up the other code? Well, then you got to go back and you got to shoot the zombie in the head, make sure you get the bonus, and then you got to go back and then drink the gasoline to make sure that it kills you, basically. So like you have to, as you keep adding more and more and more to your application, the amount of stuff that you have to test like just increases, and it gets to the point where you can't test all of it. And so that's where bugs are introduced, because you cannot test all of it. So that's where test frameworks come into play. If you can write tests for everything, then, or for the vast majority of your application, then when you create a new feature, you now have the confidence that all the other stuff didn't break, because you're now writing tests to make sure that that all that stuff is being verified. So that is the main benefit of all of this. And then, so when you think about like programming, when you think about programming like little projects for yourself, I say little on purpose because you're a one-person show, and yeah, you can create a lot, but you're not going to compare it to a 100-man team or a 100-man division where we're talking to hundreds of thousands of lines of code or millions of lines of code. How do you know that you're not breaking somebody else's code? And so that's another place where tests come in. Not only do they help you stay bug-free, but they actually also protect you. So I like using this example a lot. If you come in and you change something, right? Let's say you come into the office and they want you to make it where on Tuesdays there's a 20% discount, right? So you go in and you change all of that code and everything's good. And then 2 weeks later, Joe Programmer comes in and he writes code and then everything gets deployed. But then when you get deployed, you see that on Tuesday you get 50% discount, not 20% discount. Who are they going to call for that issue? Well, they're going to call you because you work on the discounts, and they're going to say, what the heck happened? We told you to do 20%, not 15%. Well, you go back in there and you look at the code and then you realize, oh shoot, Joe Programmer added a 5 at the wrong spot in the wrong space, and he added the 5% tax to the discount variable, and he made it so that it reduced the discount. Nobody's going to notice that. The only way people can notice that is if you write unit tests for your own code to show that yes, you did test and verify it. And then when Joe Programmer comes in and he adds his code, when he tries to run his test to do the PR, the tests are going to fail, and they're going to tell him you broke something within the code. You got to make sure to fix this. And so at that point, Joe Programmer is going to be like, oh, I added the 5% in the wrong variable. I got to go back and make sure to put in the right variable. And then that way, that right there saves you so much headache. So it puts the blame away from you. If you do a good job, like they can't blame you for it because you're not the one breaking the test. It's another developer that's breaking the test. And then they'll make sure that he's the one that fixes it, not you. So it also saves you time as well. All right, so let's get started with this. So in IntelliJ, we're going to start with pizza control. Let's not go pizza. Let's go to pizza service. So we're going to start with pizza service here. And what I'm going to do is I'm going to right click here, show context actions, and then I'm going to create a test. And so when you create a test, you're going to be using JUnit 5 most likely, or you can use JUnit 4. They're both common in enterprise. JUnit 4 is older, but you can see here that's not found in the module. So we're going to use JUnit 5. We're going to hit OK, and you're going to see here that in the main of Java, this is where your main application is, your production code. But there is also a copy of all of this stuff under the test folder. All right, and so we made a pizza service test automatically generated by IntelliJ. It's under the com example demo service package, which is right here. So the pizza service test is here, and it corresponds with the service pizza service over here. All right, so there should be a one-to-one relationship for all of your class, all your classes in the test directory. Okay, so now that we have this, we're going to go ahead and run one test. So let's just do at test public void dummy like this, and then we're going to assert true like this. Okay, so what we're saying is the value in here, does this evaluate to true? And if it does, then we got a green light. If it doesn't, then our test fails. Okay, so I'm going to change it to false to show you the test failing. So I'm going to go ahead and run this. I'm starting very simple, I know, but not everybody is familiar with tests. Okay, so it's taking a while for it to run. Okay, cool.
It's been approximately 1 year since my unit on unit testing.
Okay, cool. Let's go simple then. So dummy here is failing right here. It says assertion failed error. It expected true, so it was saying you expected this to be true, but it was actually false, and so that's why this test now fails. So to make this test pass, you type in true like this, and then when you run this, this will now have a green circle saying yes, whatever you pass in here. So actually, it's better like let's do this. Boolean value is equal to true, and then I'm going to put assert true value like this. So I'm putting true inside of this variable, and then I'm checking the variable to see is this variable true or not. If it's true, the test passes. If it's false, the test does not pass. So I'm going to go ahead and run this. Okay, and then we see right here, oh, yep, we see that it passes. There's a green check mark, everything's cool. All right, so let's go on to the next test, public void. And what we want to do is we want to check, what methods do we have in here? We have a method that says generate pizzas. Ooh, that's interesting. I like that, but we'll do another variable. We're going to do another pizza. We're going to do public pizza. Let's generate a random pizza. Or no, let's make a recommendation. Okay, and so this method is going to return some sort of pizza. Okay, so when we go back to pizza service test, so like, okay, let's think about this. So in the pizza service here, this make a recommendation is going to create a random pizza for you, right? So what we want to do is we want to create a pizza object. We then want to add the toppings, right? The random toppings, pick a random size. And then we want to return the object. Okay, so if I told you, let's take a step back from the code. If I told you to write this method, how would you guys do it? Give me some ideas. No right or wrong answers. How would you guys, if I told you to do this, how would you guys write the code out?
Wait, what are the constructors again for pizza? Like, what are you?
You can do a constructor here. You have an ID, a null ID. You have your pizza size. You have marinara, Italian. There's a display name. There's a crust. Let me go in and I'm going to split this to the right.
I would probably start with the new constructor, blank constructor with no properties assigned.
Okay, I like that. All right, so let me just make sure that, yep, it's happy now. Okay, so on the pizza service, I'm going to close other tabs. Let me close this here. So we have our pizza service, which is generating a new recommendation, and then we have our pizza here, right? Okay, so you guys said you want to create a new constructor, right? So you go pizza is equal to a new pizza with nothing in there, right? And then what else would you like to do if you wanted to randomly generate it?
I'd create lists of possible, or arrays of possible,
cool,
values for each property, and then
like
you can use the rand enter.
Yeah, that's great. That's great. So let's do what kind of let's do one for crust. So list string crust values is equal to list dot of, and then what are there's thin crust, and what else? Thick crust, or what else is there? Deep dish, right? Anything else?
Aren't they like enums or something?
No, we have enums on the pizza size.
Oh, size. Oh, that's right. Okay.
Yeah.
There's hand tossed.
Hand tossed, nice, I like that. Hand tossed. All right, we'll keep that like that for now, and then we're gonna have another one. If you do size dot value, or if you do this is a trick with enums. If you do pizza size, remember pizza size has the small, large, medium, extra large values. If you do pizza size values, that already gives it to you as an array. Okay, so we're gonna do list pizza size, and then we're gonna put pizza size values equal to new array list, and I'm gonna put what is it? You're not liking that? Oh, there you go. Oh, okay, I guess we don't need the array list. We can just do it like this. All right, so basically I'm taking the values, which is an array, so it's coming back as an array of pizza sizes, and I'm putting them into a list. So I'm consistent with using lists. That's the only reason why I'm doing it. You can still use the array if you wanted to, but I'm doing it like this so that we can always have a list here, basically. All right.
Okay, I was going to ask if it would make sense to make it a final static array, so it's fixed.
Yeah, you could. Yes, you could totally do that. I'm just doing this way. I'm trying to be as simple as possible, just so that we don't worry about us trying to make it look fancy or anything like that. But yes, you're absolutely right. You can totally do that. All right, we can just keep it like this now, right? And so now that we can figure this out for the rest of them, right? And then for one of them, we can do something like pizza size values dot get, and then we can do math dot random. Is there anything else we can do? Nope, math dot random times pizza size values dot size, like this. So the index is going to be equal to that. And then let's just change variable type, more actions. Can we do? Okay, what aren't you liking here? Oh, cool. It's just a pizza size. Okay, so what I'm doing here is I'm generating a random number between 0 and 1. It's a double that's between 0 and 1. Okay, then I multiply that by the size of the pizza size values. So the pizza size values has four different options. So if you made this into array, the size of this will be 4. Okay. So pizza size values is 4. So math.random times 4. So 0 to 1, 1. So 0 to 1. Math.random produces a value between 0 and 1. 0 inclusive, 1 exclusive. That means it goes from 0 to 0.9999999. You can never get 1. Okay. We're going to take advantage of that property. So if you take math.random and you multiply it by the size, then the number that you're going to end up with is a number between 0 inclusive and 4 exclusive. So 0.99999 times 4 is going to give you like 3.9999. All right. So we end up with the number between 0 and 3.9999. And then what we do is we typecast it to an int, which means I want you to take this double and turn it into a, oh, I have to put parentheses around this because it told me that. Oh, anyway, let me explain what it's doing. So when you take this number and you multiply it, you get a number between 0 and 3.9999. But then what you do with the int, you convert it to an integer. So you just truncate it or you remove the decimal point after that. So instead of 0 to 3.999, you end up with a 0 to 3, which coincidentally is also all the different indexes for your array. So this is a nice little trick to get you a random element from a list or array. Okay, you can do it for everything. Now the problem with this is this number right here of 0 to 0.999. This typecast is taking precedence over this entire evaluation. So we are converting the math.random to an int first, which makes it a 0, and then 0 times the pizza size values.size, which is 4, is always going to give us a 0. So that's what this warning is. When you highlight this, it says right there, result of int math.random is always 0. And the reason for that is because random only returns a value of 0 to 0.9999. If you make it an int, it reduces the decimal point and you end up with 0. So to fix that, we're going to put parentheses around our math.random and pizza size values.size because we want this thing to evaluate first. So this number times 4 is going to give you 0 to 399. We convert it to an integer, and now we have 0 to 3. So it's pretty cool. All right, so now that we have that, we can now set the pizza size to our random size, right? And then you guys just return the pizza, I'm assuming. Are we cool with that? Any questions?
You don't want to use the crust values?
Yeah, we can do all that stuff too. We can do, I mean, so to do that, you could just do the same
Same
thing here. Yeah. Let's do it. Why not? Let's get fancy. In honor of Yoon, I'll try to do it in one line. So we're going to do crust values. And look, you can even make this a, because you have repeat, look at this pattern here, right? We have a pattern here. This is, you can use a method for this basically. And if you guys want, we can go through that later on. But I'm going to pizza.set crust. And then we're going to set the crust to whatever's inside of here. Okay. Any questions on this so far? Okay. So now that we've covered the logic a little bit, how would you guys test it? Don't even tell me how to write the test. How would you actually manually test it? What would you guys do?
Just basically print out what its result is over and over again to see if it seemed like it was truly random.
Yeah, okay, that's one way of doing it. What else? I mean, what other tests can you do? Like, think even more granular. What happens if you got null?
I was gonna say, yeah, either putting a null value and also consider hard coding.
Yeah. Oh, cool. Yeah. Yeah, I think I picked a bad example because this is a little bit more complex, but I mean, we can try to make it work. Yeah, I guess we can make it work. Okay, so these are all very good points. Very good points. Okay, because you're showing me how to go in and you're kind of trying to figure out, okay, how would I manually test this? And you're understanding that you got to go in, you got to display it, print it out, and then check it somehow, right? All right. How about let's take another step back. How would you test? Let's say I'm 14 years old. I don't know how to drive, right? But for whatever reason, you're giving me the task of figuring out if a car works. So I'm asking you, hey mom, how do I know if the car actually runs? And that's actually a stupid example, but anyways. So now you got to tell me the instructions. How would I figure out if a car runs? And I'm not a mechanic. I'm a 14-year-old kid. So what kind of instructions would you tell me for that?
Get the keys,
You mean like turn it
open
on?
the door.
Okay,
start the
good.
ignition, start the
I love how you already dubbed it down for me. You get the keys. You just didn't jump in to say, hey, you got to start it. No, you said get the keys. And what was the other one?
Open door.
Open the door. Yes, that's very important. Next one.
insert the keys in the ignition.
Yeah, insert keys in the shit.
Put your foot on the brake pedal, I guess.
Yes.
Turn
Yeah, put on brake pedal.
And then turn the ignition.
Turn the key. Rotate the key. Turn the ignition.
Push the button.
Oh yeah, push the button. If it's the newer cars. Turn the ignition, and then what? How do you know if it actually starts or not?
Listen for the sound, feel for vibrations.
Okay, yeah. So good. So assert that there are vibrations. Assert that you can hear the motor, right, or the engine. What else? That's pretty much it, right? Like that pretty much tells you if a car started or not.
Yeah, more or less.
Can you think of anything else?
I mean, if we're gonna get really mechanical guess you can go out and open up the hood and see if most components.
Well, yeah, no, we don't want to do that because our user is not a mechanic. Our user is 14-year-old.
Getting mechanical, we can see if the dashboard lights up.
Oh, good. Assert that dashboard lights up. Good. Yeah, because it could be an electric vehicle. Okay, great. So these are excellent examples. So when you think about this, right, the vehicle has an interface. So the interface are all the dials, the dashboard, the ignition itself, the fact that you have to put a key into that, the fact that you have a button that you can push to hit start, the fact that you have to put your foot on the pedal on the brake so that the car doesn't move when you start it. Like there is an interface to the vehicle itself. And when you are testing it, you're not telling the user, open up the hood, look into the engine, and make sure that it's like you don't go into those details. You don't want to go to those details with your user. You want the user to be able to just get in, start it up, and go. All right. And so tests are very similar. Okay. You don't want to tell other developers, oh yeah, you got to go in there and make sure that you're using the bubble sort, and like no, you just want to let them know, like, look, when you come over here and you check out my program, it's going to sort them for you, and this is how you would test for that, basically. So when you think of tests, think of how would you test it using the interface of the application. Okay. So here in our example for the pizza repository, the dashboard or the dials are the methods themselves. So if we want to generate pizzas, somebody calls the method generate pizzas. They don't create an instance of pizza repository. They don't do any of this stuff, nor do they have to care about any of that stuff. All they do is they call the method generate pizzas, and they should expect a list of pizzas. Same thing with the recommendation. We don't care how any of this stuff is implemented per se. We just want to make sure that we get a pizza at the end, right? So that's called black box testing. Testing in the ignorance of the insides or the inner workings of the thing that you're actually testing. Okay. So I'll give you another example. Like let's say you want to add two numbers. So 2 + 2 = 4. There are many ways you can actually implement that if you want to get really fancy, right? Like if you wanted to use like some sort of binary math or something like that, you could totally do that. But at the end of the day, all I care is that 2 + 2 = 4. And so however you get there, that's up to you. But the tests are just there to test. The tests are there to ensure that the functionality is there. The implementation can be done however you want. Okay. And so when you write tests like that, then it gives you a lot more freedom in being able to refactor. Okay. So in the example of this, if you wrote a test, let's say that says you got to make sure that the engine is vibrating, and you got to make sure that the red wire is hooked up to the B sprocket. I don't know, I'm making stuff up. I don't even know what I'm talking about. So if you get that detailed when you're writing your test, you're going to actually make it harder to refactor, because then when somebody comes back and they're trying to change it, they're going to be like, wait, we don't even need a red wire. Like we don't want this new implementation runs on gas. We don't need a red wire. Like I'm going to have to erase this test. So you want to come and so my point is you want to make sure that you're testing everything based on the interface as much as possible. I'm going to show you examples where you can't do that, but you want to test to the interface as much as possible so that it is so more like black box testing, so that the insides don't really matter. Whatever the implementation is, just as long as the results are right, you're good to go and you can keep on going. Does anybody have any questions on that? Okay. So how do we write the test for, and if you do have questions, please feel free to stop me. So make a recommendation here. So you guys, so what were the steps again that you told me? You print it out, right? So to test the pizza, you print it out, and then you make sure that it's not the same. Is that what you guys said?
Well, what is that that function? What is it supposed to ensure comes out? Like you're ensuring that you have a random pizza?
I guess.
So does that mean you have to check if after you do like, I don't know, 40 pizzas, that at least you have a distribution?
Yes.
Or is that too much? Is
No,
like,
that's good. That's awesome. Yeah, in this case, you're never going to run into this. That's why I said I picked a dumb problem.
yeah,
But there is a way around it. So that's why I was like, maybe we can work with it. Yeah, there is a way around it. There is a way around it. Okay, so print it out. Make sure it's not this. Make sure it's not the same value, right? Okay, so let's go ahead and write the test that does this. Okay, but first we're not going to do this. We're just going to do print it out. And for that, let's go back to our pizza test. So I'm going to go back here to project. I'm going to go back here to the pizza service test, and I'm going to move it over to the right so that we can see it and this one at the same time. Okay, so the question is, how then do you test this service? So what's the first thing you want to do? So the way I like writing this is I start with make a recommendation. So I start with the name of the method, and this is how I organize it. So you'll have multiple methods that start with make a recommendation, and then you explain what you're trying to do. Okay, and the easiest way to do that is start with should. So should return non-null pizza. So that's the first thing you got to do. Check to see that it's not returning a non-null pizza. Okay, so how would you guys actually test that?
just create a pizza using that method, and then just assert that it's not null.
So how would you create the pizza with that method?
Don't you gotta create a pizza? Like just.
Well, I'm testing this method right here. So how do I call this method? And I have a blank slate of code.
You have to call the pizza service.
Yes, good. I have to call the pizza service. So if I want to call the pizza service, what do I have to do first?
I would probably create like at the top a final pizza service.
Yeah.
A setup where it actually instantiates it.
Good. So you're doing an advanced thing where you're doing it for every test, basically, right?
The setup, yeah.
Yeah, okay. So before we go into that, let's just create it in here. So we're doing pizza service, and we're going to instantiate our pizza service, right? There we go. So now we have an object of the pizza service. Does this make sense?
Yes.
We're good here? Okay, now we're going to do pizza service dot what? Which method are we testing?
Make a recommendation.
Yep, perfect. And so what does make a recommendation return?
A pizza object.
There you go, pizza. So pizza is equal to pizza service dot make a recommendation. And then what do we want to assert?
That is not null.
Yeah, so let's just do, I think there's an assert not null. Not
Yeah.
null, yeah. Assert not null pizza. So as soon as we did all this and we run this, this should actually pass. Great, this passes. But what happens? So now that we have this right here, right? There's a lot of things that could go wrong with this test, but this test is a good start. Can you guys tell me ways that this can be cheated or this test is not good enough for our purposes?
It could just be a hard-coded
Yeah.
pizza.
Yeah, I could just do this. I could just return new pizza like this, and there's nothing in it. And so when I run this, this is still going to pass because I'm just checking to see that it's not null. But it is, yeah, it's not null. There's something there. Does that make sense?
Correct.
So the question is how do you write the test to ensure that all of this is being populated? So
You do one test for size and then another test for the crust to see if you get those values.
yeah, you can do that. Yeah, or you can just do assert not null pizza dot get crust.
Oh, like it has one of them.
Yeah, and then you can do assert not null pizza dot what was the other one? Get random size, get size. So that's another way you can do it, right? So now if you run this, it's still going to be good, but even then, so at least it fixes. So this passes, right? But at least it fixes this. So if I just create a new instance of a pizza, this should now fail because I did not actually populate the crust or the size. Yeah, see? So it says it expected not to be null, but it was null at line pizza service test Java 21. So if I click on this, it takes me right here. It says this thing was actually null. It's not supposed to be. Any questions on this?
Is it okay to use multiple certs in one test method? Or
Yeah. It depends. I'll leave it up to your judgment. Typically, you only want to test one thing at a time. So yeah, only one assert. But in this case, we're testing the whole entire concept of this is that we want to make sure that it's an actual valid object, right? So in this case, I think we're justified in using multiple asserts in one test. Okay. So before we get deeper into this type of stuff, we're going to want to figure out the 3 A's of test-driven development, or actually of just test in general. It is assert. No, it's is it arrange? Almost forgot it. Jeez Louise. Act, assert. Okay. So these 3 A's. I would highly recommend you memorize. Arrange, act, assert. Okay. So the first thing arrange is it's all the steps to get you to the moment of truth. And I say that in the sense of in our example here with the shoot, where did I put that text? When we gave you all the steps, when you were telling me how to actually check the vehicle, right? There was a bunch of steps of preparatory things I had to do before I could actually put the key into the ignition, right? It was I had to pick up the keys, I have to go open the door, I have to sit down, I put the key in the ignition, I put my foot on the brake, and then at that point, then I can turn the ignition to see if it works. Okay, I can't teleport in there. I can't turn the ignition at the beginning because I need the keys, right? Like I have to make sure my foot's on the brake before I can actually turn the ignition. Otherwise, it's not going to turn at all, no matter what. So like the arrange aspect of the testing is everything you have to do to get ready for the actual moment of truth. Okay, the actual, and there's only one action that tells you does it work or not. Okay, if there are multiple steps, then you're gonna have to break that up into separate tests. But there's only one action that tells you, okay, here's the test. So here the act is it's the method call. So it's a method call, and it is the method you are testing. Okay, and it may sound weird that I'm being as specific as that, but it's not. Like it is always one method that you're testing, and you're expecting something to happen at that point, whether it's passive or whether it's being returned to you. Like there is something that you can then check against that, and the assert is the actual check. Assert is the check to ensure the behavior is working. Okay, so assert means did I get the expected result? Yes, the test passes. Did I not get the expected result? No, the test does not pass. So this looks very simple. Oh my gosh, this looks very simple. However, when you are facing a clean slate and you're trying to write tests for yourself, it's like the worst case of writer's block. You don't know where to begin. You don't know how to start. Like that is where things can get complicated. Okay, so tests, especially with test-driven development, if you can write your code specifically for tests, then your code is much easier to maintain. In fact, there's a quote that says, if you cannot test your code, then it does not work. Like that statement is so bold as saying it does not work because yeah, how can you test? Like if you can't test code, how are you supposed to know if it works or not? Like remember how I said you're always testing, but if you can't test that it works, then how do you even know that it works? You it's impossible, right? Like you have to get some sort of verification. So yeah, so now the question is, how do you write tests? What are the examples, or how can you make it so that you can write easy tests? So first things, let's think of this. So in this case, we wanted to make sure that we wanted to return a pizza, right? So one of the things that we want to do is when we're writing this code here or make a recommendation, the very idea. So instead of just doing this, right? So like this is like how ingrained in my head it is, and I have to remind myself that it's not like that with everybody else. If, let's say I told you, hey, yeah, let's make a recommendation, and then you do something like this. Oh yeah, I'm going to S out, and then I'm going to do a new pizza like this, right? Like that right there is not as easily testable as this right here. Does that make sense? Can anybody tell me why you think this one is easier to test than this one?
It returns an output directly, and you don't have to like intercept. You're looking
Yes.
at the system.
Exactly. So in this case, if you wanted to test that the recommendation was actually coming out, you would have to exactly what Chris said. You have to intercept the print. Like, how the heck are you going to do that? I don't know. You have to Google that. That's crazy. This is advanced coding now at this point. Like you have to intercept the output stream to then ensure that you have a pizza there, right? And then, but with this one's a lot easier because all you got to do is call the method, and the pizza comes out. And if the pizza comes out, then you're good. So this is a very good example of how coding it specifically or coding it for testing can make your life so much easier. Does that make sense? Yes? No? Everybody cool with this?
Yeah.
Okay. All right. So that's one example right here. Another example is stuff like, so number one is you always want to be able to make a way to return stuff. If you have this, a public void, and then you have some method here like this, that is kind of a red flag. I'm not saying that you can't use void, but when you have some method and a void, you're going to need some other way of verifying what this behavior is. Okay. You got to have a very good reason for not having a return type here, basically. So that's one thing to take into consideration. Another thing to take into consideration is sometimes you're going to see methods that have stuff like logic 1. These are big logic things. They're going to have logic 2. They're going to have logic 3. They're going to have, like I'm telling you, this is how it is in enterprise. They're just going to have so much stuff in here, right? Evaluation, and then they're going to run more stuff, and then else, and then they're going to have more logic, and then they have additional logic and more logic. So how... I feel for anybody who has to deal with this because I've dealt with it many, many times. How the heck are you supposed to write a test for this? If you have logic 1 and 2 and 3 and 4, and then you have this and all this and then this and this, like the number of permutations there are is, and it gets even worse if they do something like this. If evaluation 2, and then they have another if statement, and then inside of this also they have another if statement. So now you have nested ifs, right? You're going to see code like this, unfortunately. So if you have 3 ifs here, right, you actually have 8 total combination of variations, I think. I might be wrong. But like, so if this one is true, then you're gonna have to deal with the true version of this, and you got to deal with the false version of this. And then if this one is true, then you got to deal with the true version of this, and then you got to deal with the false version of this. And then if this one is true, then you got to deal with the true version of this, and then you got to deal with the false version of this. Okay. So as you continually as you add nested if statements in your code, you're actually introducing. It's kind of like the multiverse. Like as soon as somebody introduces an if statement, they've created a whole new branch in the multiverse, a new timeline that you now have to follow. Okay. And so if you keep doing if statements, you are like creating all of these different pathways that you got to be taking care of, that you got to then write tests for.
Never nest.
Yes, that's a huge. That's like that's one of those nuggets of wisdom is never nest your if statements, and this is basically the reason why. Okay, so that's that right there. We have all of this. We covered return types and why returning data types are so important. Okay, so now that we have that, let's go ahead and take this out, and then let's actually go back and start testing this guy some more. So following this arrange, act, assert, right? Let's go ahead and make another test. So I don't know how the heck you're supposed to test that a thing is randomly distributed. I guess, yeah, we do. So make a recommendation should have even distribution. Oh my gosh, why did I pick this? So the way you would do this is, first of all, if you're introducing the for loop inside of your test, that's bad practice. Like you want to keep the test as simple as possible. You want it to follow these 3 steps. You arrange, you act, and you assert, and that's it. Okay, but because I chose stupid random, we can still solve. We can still deal with it. Okay, so what we want to do is basically we'll do for int I equals 0, I less than 10,000, I plus plus. So we're going to iterate through this 10,000 times. Then we're going to let's create a hash map here. So we're going to do a map, and it's going to be of pizza size. And we're going to do, this is going to be horrible. Sorry. Then we're going to do an integer here. So we're going to make this a counter. Okay, and so let me make this pizza size like that. Okay, so here's a cool trick. Let me do all this right here. Sorry, and I gotta make the hash map here. Okay, let's create a new instance of the map. Okay, so here's the trick. So as we start going through this, right, we're gonna do. Oh, we gotta create an instance of our pizza service. So this is all in the range. Pizza service is equal to new pizza service, like this, right? We're making our counter, and then in here we're going to then call it. So pizza service dot generate pizzas. Nope, make recommendation. So pizza service dot make recommendation. We're gonna put that inside of a pizza. All right, and then what we're gonna do is we're gonna then count. So we're gonna do counter dot so int count is equal to counter dot get or default, and we're gonna get the pizza size. Get size, and then if it does not exist in the map, we are returning 0. Okay, so it's just a shortcut. We're trying to see if the pizza size enum exists as a key inside of the map, and if it doesn't, then we are going to return 0 because that means that there are 0 instances. There are 0. That's a 0 count. We haven't encountered this pizza size yet, so the count for this should be 0. So then we're going to take that count, and then what we're going to do is we're going to increment it. So we're going to do counter dot put, and then we're going to put in the pizza size, and then we're going to pass in count plus 1 like that. Okay, so this will make a count. We'll count all the pizza sizes that are generated, and then after we run it, let's go ahead and test it. So s out counter, and then we'll see what the numbers are. So let's go ahead and run this test. I still have no idea how we're going to do even distribution. So there's kind of an even distribution, right? There's 2,477 medium, 2,500 large, 2,515 extra large, and small is 2,440. Does that make sense? Now the question is, how do you? Then let's rerun it again and see what happens. I mean, it's kind of an even. It's not exactly an even distribution, but you could tell, like, yeah, this is looking like there's stuff that's random here. So how would you guys write a test for this, even if it's like a bad test, not like mathematically accurate? What kind of a test do you guys recommend for this?
Could you, I mean, it seems like they're within about 200 of each other, so could you just verify that everything was, say, between 2,300 and 2,700 to give yourself a pretty good margin of error?
Yeah, let's do that. So what we can do is we can then do a assert. Is there an assert in range? That'd be kind of cool. Assert range? Nope. Nope. So assert equal or assert true, and we're going to assert that counter dot get, and this is where you do your hard coding. So you want to do pizza size dot small. We'll do small first, and we want it to be greater than 2,000. So you said 2,300, but I'm just saying let's just say even greater than 2,000, right? And then what we're going to do is we're going to do the same thing for all of these, and then asserts, if they're false, they just tell you, they give you like a message that doesn't really tell you anything. They're just gonna say it expected false or it expected true. It doesn't really tell you why it failed. Okay, so what I like to do is I put a comma. This is only for assert trues and assert falses. So I'm gonna put a comma here and I'm gonna say small is not distributed. Okay, or I'll just put is not distributed. Okay, and then what I'm gonna do is I'm gonna copy this, paste all this here, and then we'll go back and make sure that we have medium and all that here. So medium. Notice how I am hard coding. I'm not trying to do a for loop here. I don't want to do a for loop. I want people who come in and look at this because this is my documentation. You don't need comments. Your tests are your documentation. So when you go over here, make a recommendation should have even distribution. Okay, cool. I understand what he's doing here. So pizza service equals to pizza service. I get the counter. I'm running this thing multiple times, 10,000 times. I get the counts, and then I assert that all of these are greater than 2,000, right? And then if you wanted to, you can then assert that they're all less than 3,000, right? So let's go ahead and do that. And you're never going to see a test like this in production. I picked the wrong problem. So, but this is how you would actually try to test something like this. Okay, so now when we run this, we should now get a pass. And when we print it out, we see that extra large is 2551, small is 2494, large is 2495, medium is 2460. Is there a problem with this test? Do you guys think there's a problem with this test? Mathematically? Say it.
I mean, like it's not perfectly
yeah,
legit.
It's not perfectly legit in the sense that, yeah, it could be randomly generated, but there could have been one that comes in at 2,000.
Right, and the other one comes in at
then you break your test. And then what that's going to do is, if you have your CI/CD pipeline and everything's set in place, somebody's going to run the test and it's going to fail. You're like, oh my gosh, I have to rerun the whole pipeline again because this thing just kicked out my thing. And you also don't know if it's truly not random type of thing, right? Like, what if you have a new programmer who doesn't even know that this is supposed to be a random test, like it's testing randomness? You know, like this could mess them up basically. So, I mean, you could also say, oh, this might be a better test, that they're all greater than 0, right? You get what I'm saying? Like, that might be better that they're all greater than 0.
Why is that better? Isn't that worse? Because
Well,
if you have one, and then the rest are like 4,000.
But at least this also shows that all 4 have more than one, basically.
Oh yeah.
More than 0. I mean, so that means that you just didn't hard code small. You're actually generating stuff. But the problem is that this is not even telling you. This is not even testing randomness either. This is really not even testing randomness. This is just saying that you have more than 2,000 values here.
I was going to say you don't know the type of distribution. You're
Exactly.
assuming it's a normal distribution, but
Yes.
that may not be the case.
Exactly. Yes. Yes. So this is. I just wanted to showcase this to you. Like, this is how you would try to test something like that. There's actually a better way of testing it using dependency injection. But we can cover that. If we have time, we'll cover that. Okay. So this is how you would write that test, right? And so let's look at the. Does anybody have any questions before we move on?
Are you gonna do the whole before thing?
Yeah.
To
Yeah.
set up?
Let's do that. Let's do that. So as Chris was saying, there's a lot of repeated code in here, right? And so some of the repeated code is you have to keep creating an instance of your pizza service. So one thing that you can do is you can create a field up here called pizza service. And this is very popular too because you can reuse this throughout your test. But now we have pizza service. We're going to create the annotation of before each. And I always like calling it public void before each test. Some people like calling it setup. You'll usually see it set up in your tutorials. But this method before each test gets executed once before every single test. Okay. And so in here, we're going to then instantiate the pizza service. So we're going to do pizza service is equal to new pizza service like this. And then now that we have this, we can now delete this and we can now delete this. And so now that we have all of this in place, we can run this code and it'll still pass. So let's go ahead and run this. Nope, I messed something here. What's wrong here? Yep, everything's cool. Let me get rid of the dump. So what we're following is, if we were doing true test-driven development, we would be following these 3 phases. Okay, red, green, refactor. Okay, so when you write your test, you actually want to write your test first so that it fails. You have to verify that your test fails first. Very, very important. Because if you just write code and just like if you just write code and then just leave and not test it, you don't even know if that code's if that test is valid or not. So yeah, I mean, I've run into this so many times, especially with async programming. If you don't verify that it fails, then you can have a useless test that doesn't really protect you from anything. So how do you do that? How do you ensure that a test fails? The way to do that is to just change the code in here to make sure that this test fails. So here it says make a recommendation should return non-null pizza. Okay, so all I'm going to do is just return null here because this thing is saying it should return a non-null pizza. Well, if I return a null pizza, then this thing should fail. So I'm going to go ahead and run it. And then this thing should fail, and then you can then move on. Yep, it fails. So this test works in the negative case. I'm going to control Z this and then rerun it again, and it's going to be green because now it works in the positive case. So that's something that you want to do with all your tests. And it doesn't take that long, especially as you start getting better with these things, then it becomes second nature. Make a recommendation that should have somewhat even distribution. Okay, so what I can do here is I can do pizza.set size to pizza size small. So I'm setting all sizes to small. Okay, and so when I run this, this should now fail because it is not distributed because small is going to have 5,000. So small will be 5,000 and it should fail on the medium. Oh, cool. Look, it failed. It failed because there's no medium. There is no other. There's no other. The key does not exist in the map, so that's why it fails. Oh shoot. Let's do medium. That's not going to work either. It's actually a. So I mean, the test failed because there was an actual exception, but from a documentation perspective, what you should be doing is. Nah, this is fine.
Wait, are you saying you do this when you're making a test? You try to break your code so that it catches it.
Yeah.
And then you do that one time, and then once you know your test catches something.
Yeah.
Then you just test it like as normal. You don't have to automate your failure test case or your scenarios.
No. Yeah,
so
no. You don't have to. You don't have to go crazy.
One time.
Yeah, you only have to do it one time. You don't have to go because I know you have a testing background. Like this, we're just looking for. You don't have to get that crazy with it. You just want to make sure that the test fails because that means it's working, and then you can go forward with it. And typically, you test a happy path and a negative path. You check for both of them basically.
So your red process is a one-time thing, and then your greens are just the rest of your. That's always.
So no, I'm sorry. So the red, green, refactor is all for one test. So your red is you make sure it fails, then you make sure it passes, and then if you can clean up the code, you can then change stuff like we did right here with the before each and all that stuff. Okay. So that's basically refactor means you can change code in here too if you wanted to. But that's the beauty of tests. Oh, they're so awesome. If you have a huge test suite, and I saw this with SoulQuest, I wanted to add a new weapon that like took extra damage or whatever, right? No test. You add it, you introduce it. Oh, the shield breaks. Oh, that spell breaks. Like the tests help you out so much because as soon as you break something, the test will tell you, oh, you broke this. Shoot, I got to go back. I made this a null pointer instead of like you gotta. The tests definitely help out with that. They identify bad things quickly. And so yeah, for each individual test, red, green, refactor. And so the refactoring is just so important because that freedom, you can get to a point where you are afraid of touching code. That's the worst. If you are afraid of touching code, then you don't want to code because you don't want to break it, right? So like, you do not want to be in that situation. You want to feel relaxed about your code. You want to feel like, oh yeah, I can change it on the fly. It's easy to change. I can just go ahead and add that real quick. Like you want that kind of feeling with your code, and that comes with architecture, and that comes with testing. Okay, so let's see what we got here. Okay, so did I screw? Oh yeah. So if you wanted to get, so what I was gonna say is, you can do this if you really wanted to, counter.get or default like this, and then pass in a 0. But I do not like this because I'm introducing additional logic into this test that is not required. Okay, because what happens if this is a bug of me adding getter default, right? So if well, let me show you what I mean. Because if I run this, this will now be a prettier message. It's going to return 0 because medium doesn't exist. Yep. See, now it says is not distributed, expected true. And then when I click on this pizza service test Java 51, it tells me that it's the medium that was not distributed. Does that make sense? We can actually, you know what? Let's do it this way. I'm going to write the test like this. I'm going to do counter.put, and I'm just going to initialize all the values up front in the range so that we get a pretty message at the end. So what this is ensuring is that all of these pizza sizes exist in the map. Does that make sense? Am I going too fast for you guys?
No, it makes sense. You're initializing the buckets, I guess.
Yeah. What was that for? Okay, and so I like this.
Has given Dobby a shock.
I like this better right here because you don't want to introduce logic that you don't need into your test. So I'm just going to take this out here because it's just dangerous. I don't want any risk of bugs on my asserts. If I have to set something up, I'll do it in the arrange phase. Up
You
here.
have to update that line of code with the int count in the for loop now, since you don't have to make that check anymore. Or what?
Yeah. You can just do a get. I mean, we can leave it there. It doesn't matter. But no, let's do it. There you go. And then let's take out the 0. So now you can do that. All right. Everybody cool with this? The act itself, I just made a liar of myself, kind of, because the act is supposed to be one method call. Technically, it is one method call. We're just calling it 10,000 times. And then here's the assert. So we followed the 3 A's within this test. All right. So let's go ahead and run this. When we run this, since we set them all too small, we should now get a better. Yep. So we can see that true, false is not distributed. I'm not a fan of this either, right? So let's just go ahead and add small here like this, or pizza. Oh, there's no pizza. Shoot. Let's just do that.
You saying you don't like that because you're hard coding the name of the thing?
No, I can't. There's no pizza. The pizza. There's only pizza in here.
You're saying you don't like doing it this way because why?
No, I do like doing it this way. I'm just saying.
Oh.
Yeah, I was going to try to make it simple by doing pizza.get size, but there's no pizza there because the pizza's out of scope. There's 10,000 pizzas too. Like there's no variable that holds the size. So I'm just going to go ahead and. I mean, it's a little bit extra work, but I just want the error message to make sense. I mean, I'm very pragmatic when it comes to this, so I'm not trying to lie to you guys. I'm coding the way I would code out in the field. That way you understand, because you just want to know exactly what's wrong. You don't want to go through and hunt all this stuff. Like when you see the test and it fails, you want to know instantly, oh shoot, medium is not distributed. Why is that the case? Like you want to know exactly why. So it says right there, medium is not distributed, expected true, actual false. You can now click on this, and then you see where the issue is happening. When you click on this, it shows you which test is failing, basically. Or you can double click this, and it'll take you to the test that's failing. This is helpful when you got like 50 tests. So definitely use these links. All right. Okay, so now we asserted that this thing fails, right? So now let's go ahead and take this out, and then we can go ahead and rerun the test, and it'll pass, and then we're good. And I really like the next example. Okay, so now that we have this, let's go ahead and run everything. Just make sure everything's good. Yep, everything's passing. Now we're all in green. So let's just go back and refactor. We don't need this dummy test anymore. So let's go ahead and delete that. Now what we want to do is we want to test generate pizzas. Okay, so let's go ahead and test generate pizzas.
Didn't your test only check for the size and not the crust? I thought you were gonna check crust too.
Yeah, I'll leave that up to you guys because unless you guys want to see it, do you guys want to see that?
It's gonna be the same.
Yeah, it's the same thing. Yeah. All right, this is a new topic now. So now we're going to generate pizzas, and we are expecting 2 pizzas. We're expecting 2 Italian pizzas. Okay. All right, we're expecting 2 Italian. Should return. Let me follow my rules that I had there. Should return 2 Italian pizzas. Okay. So notice how I have the name of the method here and matching this because I'm telling everybody this is the method we're testing. Okay, and remember every act has one method call, and that's it. So we're going to go to arrange, act, assert. All right, and so our act is automatically going to be pizza service.generate pizzas. Okay, so this, I love this. When you're dealing with the writer's block of writing tests, you're always going to be like, I don't know how to write this. I don't know what I'm doing. This is crazy. So you just got to start with something. And the thing that I always start with is the method. What are you trying to test? Well, I want to test generate pizzas. Great. I write that code down. Now I ask myself, what do I expect from generate pizzas? So how can you guys answer that? What are we expecting from generate pizzas?
2 pizzas with marinara Italian.
Yep.
crust.
Okay, cool.
That's
So
all.
you're expecting 2 pizzas with ingredients, right? So because you answered that question, we're looking for 2 pizzas with ingredients. That means that your assert is supposed to be what? Well, I can tell you since you guys are not familiar with this. But as you could, like, my main point from this is that if you start with the act, you'll be able to ask and answer the questions that tell you what to do next in the code. Okay. So first things first, you want to expect 2 pizzas with ingredients, right? So, oh, well then I automatically need those pizzas. So I'm going to create a list of pizzas. And I am going to put them in here. So when I do pizza service.generate pizzas, I get the pizzas, and then I need to figure out a way to check the pizzas, right?
Yeah.
So let me see.
Does that mean your range has to have like your constant? Like your,
Yeah,
like-
exactly. So pizza, expected pizza
Yeah.
is equal to, they're both the same pizza too, right? So let's call it Italian pizza, expected Italian pizza. I like putting the word expected because it's not what you're getting, it's what you expect to get. So expected Italian pizza is equal to new pizza, and we're gonna just copy all this. Oh shoot, it has a different label. Crap. There's 2 pizzas then. So we're gonna get that pizza, and then we're gonna have another pizza. So expected pizza XYZ is equal to, and then we'll copy this. Okay, so do you see how, so we have expected Italian pizza. Let's put expected pizza. We're gonna give it the other label ABC, just to differentiate them. Yep, and XYZ. Okay, so now that we have this, let's create a list. List of pizza expected is equal to list.of, and we're gonna have they return saved one first. So they actually return XYZ first. So we're gonna do list of expected pizza XYZ and expected pizza ABC. All right. And then the cool thing is we know that a pizza, this is where Lombok's awesome. We know that a pizza is a at data, which means it has an equals and hash, which means it is now comparable by value. Super important. If you did not have Lombok in there, you would have to write a manual comparison test. But because it's Lombok, all we have to do now is do assert equals expected, comma, pizzas, like that. There's a few things we got to change, but this is basically the logic right here. Does anybody have any questions here?
So that's going to compare a list with a list?
Yeah.
And it works fine. Okay.
Yeah. Any questions? We're going to get really complicated in a little bit, so please ask your questions.
Well, right now we're not loading the Spring context, so the repositories.
Exactly. That's good. We're not loading the Spring context. Very good. Can you tell us what you mean by that? You're not loading the Spring context?
So right now we're kind of running our, like the tests run, you can almost imagine the whole test folder is an entirely different program from our main program. So we can like import stuff from the main program, but it's not like running in the same, you know, like from the same main, right? So it doesn't have all the Spring stuff. So we need to use annotations to kind of give us Spring things.
Yeah, yes. So let's look at it like this. So I'm going to go here to project, and I'm going to go to demo application test, okay? And I'm going to run this test right here. So this test has at Spring Boot test, okay? So when I run this, I am actually running Spring. So I'm running the Spring Boot framework in the background to run this test. And it's trying to load up all of the beans. It's trying to run it almost like a real program. Does that make sense? It's trying to spin up everything where it generates the beans for you. It puts them into the different services for you, and then it can try to, and then it executes. So when you see at Spring Boot test and you see this text right here like this, that means that you are running this in the Spring environment. Okay. Notice how long it takes to. It took 833 milliseconds. Spring Boot, when you run things at Spring Boot, because it has to spin up everything else, it takes a lot longer to run tests. Okay. The way I'm showing you here with the pizza service test, there is no Spring Boot. There is no Spring Boot test here. So when I run this test, you're not going to see Spring Boot, right? In fact, and then look how fast these tests are. 52 milliseconds, 7 milliseconds, 12 milliseconds. So this is what I call vanilla Java. So when you're running tests like this, you are running tests strictly from Java. Java ignores the annotations of Spring Boot. You are just running the pure Java as if the annotations did not exist, unless it's Lombok. But sorry about that. I don't want to make like a blanket statement there. All of the Spring Boot annotations are ignored when you run in vanilla Java, right? And because Lombok generates Java code, technically Java is not ignoring. Yeah, Java doesn't ignore the Lombok annotations because those annotations literally generate the code for Java to execute on. So when you're thinking about tests and vanilla, these tests are running faster because they don't have to spin up the Spring framework. But you gotta work within the rules and the paradigm of Java at this point. Okay. So what do I mean by that? So what do I mean by that? So when I run this code here, it says cannot invoke com example demo repository pizza repository dot save object because this pizza repository is null. What? How is pizza repository is null? How is that null? Can you guys explain that to me? So I try to run this method and then yeah, go for it.
Auto-wired is a Spring annotation, so because
Exactly.
we're not running a Spring.
Yes, perfect. You're not running a Spring context, so because of that, you end up with this code here, right? And if you were reading this as straight Java, you would then say, "What's the problem here?" Somebody other than Chris, because I know you know Chris. What is the issue here? Why do I get a null pointer exception? Anybody? Okay, Chris, go ahead and answer it. Why are we getting a null pointer exception here?
We never initialized pizza repository.
Exactly. You never. Yeah, it was never instantiated, right? So this is this is the problem with dependencies and this will bring up our next topic of dependency injection. Okay, so this pizza repository is called a dependency. All right. So whenever you have a class that has other classes as fields, those classes are now considered dependencies of this class. Okay, and the problem is that when you're trying to test something, so like even though I can do this, right? Even equals new. Actually, I can't even do this, but let's just say I could do something like this, right? If I try to instantiate this dependency inside of this class, I have a big problem here. Like, first of all, this thing connects to the actual database, right? I don't want to connect to the actual database. I just want to make sure that I get my pizzas. Does that make sense? Like, there are some detail, and then like spinning up a database, like, where am I going to do that? Do I have to spin up an H2 database? Do I connect to a Postgres local database? Like, how the heck am I going to get this database to execute? So what we're going to introduce is called, so dependency injection is one, and then we're going to talk about mocking. Mocking allows you to make fake instances that you can then use in your testing, okay? So, like, let me give you an example. So in this case, you might think that's a little weird, right? Like, wait, why would we want a fake database? So the reason we want a fake database is we have our pizza service here, right? And we want to make sure that the pizza service works. We only care about the pizza service logic, okay? So if I make a real pizza repository here, that is pointing to a database, and one of my tests fails, right? Well, what broke the test? Was it pizza service or was it pizza repository? So as soon as you introduce a real service, you are already opening up the question of, yeah, which one caused the test to fail? Was it the service or was it the repository? And so by using a fake service, so let's make this fake, and you control all of the behavior up front on the outside, then now you can answer that question with, well, what broke it? Well, pizza service broke it, because I'm telling pizza service exactly what it wants to know from the pizza repository. So because the test broke, I know that the pizza service is the one that broke it. Does that make sense? So I'll give you another.
You're saying fake is you're just basically saying that's your controlled data.
Yeah,
you
you control it basically. So let me see if I can draw a little line here. And it's you. This is you, Andrew, controlling it. All right. So the unit test. So a unit test is something specific to the class you're testing. It only tests the logic of the method. It does not test the logic of the internal services or the dependencies. If you want to do that, if you want to test everything, that's called integration test. Okay, and it's also called end-to-end test. And you're going to hear so many different definitions of these tests. So a unit test is the most atomic level of testing. You're testing the logic specifically of the pizza service, and that's it. You're not testing anything else. Everything else on the outside is a mock or dummy data, because you're controlling the outside, and you want to make sure that everything is working properly based on the environment that you're providing. The integration test, just the simplest example of this is, do two classes work together? That's like the basic, most simplest description of what an integration test is. When you start introducing Spring and Spring or the Spring framework, you're going to have to deal with stuff like, wait up, is the REST controller hooked up to the HTTP? Does it listen to HTTP requests properly? Like your class is using annotations for extra functionality. So that is called an integration test, because you're not testing pure Java at that point. You are testing the behavior of your Java in conjunction with Spring code. I hope that makes sense. So so what I like to call it is, when you're using the Spring context, that's considered an integration test. And when you're doing pure Java, that's considered a unit test. Okay. And then finally, end-to-end test is platform to platform. So basically, what you want to do is, does the UI hook up with, or play nice with the backend, right? And so these platform tests, they're outside the scope of bug wars. You don't have to do this if you don't want to. If you did, go ahead. But you can also automate these. But they are written in different languages. These are not going to be in your Spring Boot application. These will be outside because they have to connect with the UI and they have to connect with the backend that's probably on your development environment. Does this make sense? Everybody cool with this? Okay. So that brings us to the next thing. Let's see here. The next thing is the testing triangle. So here we go. So this is a kind of a they're all very similar. You can see that they're all different here, right? Unit test, integration test, acceptance test. But so it's very common. You're going to see this everywhere, right? But the unit tests are the ones that you have the most of. Why? Because they're fast. Hopefully you made them fast. You're using, because I've seen unit tests written with Spring context too. Everybody has different opinions of this, right? But in my opinion, I think you should use pure Java with your unit tests because you're going to have so many of them. You want them to run fast. Okay. And then the tests above this layer are the integration tests. This is where you might write a few tests here or there just to ensure that your classes are working properly with Spring. Okay. Then you have acceptance tests. Acceptance tests basically tell you these are the ones in your cards, right? So you don't have to write tests for your cards. You know how acceptance test is like something like when you log in, you get you go to the profile page, or if you try to go to the login page, you get rejected type of thing. Typically, you would be using mocks to test that stuff, but the acceptance test is kind of the real thing. You do not have to automate. You don't have to write these tests, but you should test these manually to make sure that your story passed. And then finally, there's the UI test. The UI test, they call them UI tests, but these are actually end-to-end tests. Basically, what you're doing, they're kind of like acceptance tests, but they're baked in so that every time you release, you're running those UI tests. It's like a robot running your app, basically. It's clicking buttons, making sure that the results are expected. And this is outside of scope for us too. But just know about them so you know what they're talking about when you go into the field. So let's see if there's other ones here. They have UI. So they have a manual test. They call these UI tests. They call them over here end-to-end test, UI testing. So yeah, that's pretty much it. These guys don't even have acceptance tests. They just have integration tests and unit tests. So like it's all across the board. But for the most part, it's they're very similar. Any questions? Okay. Okay, so now how do we fix this? All right, we covered the general overview of tests. Now how do we fix this guy right here? So I do not like instantiating stuff within the class itself because remember, this is a black box and I'm trying to use the interface of the class. So there isn't anything that says, maybe there is. If I could do pizza service dot set repository, right? Set pizza repository, then that means I can create my own pizza repository and put it in there. Okay, and then that way I can start making fake stuff occur. So let me show you how to make some fake stuff. So we're gonna go over here. I'm gonna go ahead and do a private pizza repository, and I'm gonna call this mock pizza repository. Because remember, we do not want. So if we ran this with Spring Boot test like this, it would try to create a database, or it'll try to connect to a database with the pizza repository. We don't want to do that. It's going to slow us down, and we don't care about database logic. We care about pizza service logic. Okay, so what we need is a fake database, and the way to do that is to use Mockito. So Mockito is something that you want to put on your resume, and you definitely want to understand it because Mockito is used all over the place. Anybody who uses Java, they use Mockito. All right. So the way to set up a fake instance. Okay, so in Java, if you want to create an object, you go new pizza repository like this, right? But with mocking, you use their library to create an instance. Okay, so the way to do that is you go mock pizza repository is equal to mockito.mock parentheses, and it's going to be the class that you're trying to mock. So pizza repository.class, like that. Okay, so what's cool about this is now that I have this done, I can now go in here and I can do mock pizza repository dot, and you can now see that all of these methods are here now, just like it's a real object. So I'm going to do get all. So I'm going to do find. Where is it? There should be like a list all or get all, find all. Anybody see it? Get all or
It should be find all if you start.
Oh, right there. My bad. There you go. Thank you. So find all. So I'm just going to S out what's inside of mock repository find all, and then let's go ahead and run it and see what gets displayed here. So notice how I'm not getting a null pointer exception. Like this thing's actually trying to execute something, but something failed. Let's see what happens. Oh, look, I got an empty list. Okay, so Mockito has automatically made the find all method because it's supposed to return a list. It's automatically made it return an empty list. Okay, that's kind of cool. What happens if we do s out mock pizza repository dot save, and I'm going to save a new pizza. What do you think will happen if I call this method? Any ideas?
Does it put a pizza into your repository or something?
No.
save do?
It's fake.
Right.
It's,
I mean,
it's a it's cardboard.
that's what I mean,
It,
in
it's
testing.
legit cardboard. It's not even. It is all a sham. So when I play this, what's going to happen is I'm going to get null.
Oh, because I think it's just no. Oh, I see.
Yeah, I get null because by default, any method that you call, well, except find all. I don't know. I didn't know about that. But if you click save and you're trying to return an object, you didn't tell it what to return. I mean, it's that dumb. It doesn't. It's like, oh, you didn't tell me what to return. I'm just going to return null. And so that's what it did right here. It was a little bit smarter with find all because it knows that you're trying to return a list. So it just said, okay, here's an empty list. And it's kind of cool that they did that because if they return null, it would actually break your code. But with this, it makes it easier for your code to run through because for any for loops that encounter this list, it's not going to break. The for loop will just say, oh, there's nothing there. I'm going to keep on going. So this right here is, notice also that mock pizza repository is an object. It is an object. It's definitely an object. If I do s out mock repository, it's going to say that it's an object, but it's going to be a different type of object. So when I run this, it's going to say that it's a mock object of type mock pizza repository. Yeah, see, mock for pizza repository hashcode 939475028. So this mock for pizza repository should tell you like, yeah, we're trying to simulate a pizza repository, but it's not actually a real pizza repository. If you call .save or .delete, I'm not doing anything. Like there's nothing, there's no database that it's connected to. There is nothing. This thing is just a shell, and we are simulating the behavior coming out of it. Okay. So in this case right here, right, this is where we got to start like simulating how it's supposed to look. Okay. So, oh yeah. So here, even though we save a null pizza here, we're expecting that when you do pizza repository.save pizza, you're expecting a pizza to come out with an ID already in it. Okay. So we're going to save XYZ first. So if we simulate the behavior here, XYZ is going to come out with the number 1, and then ABC is going to come out with the ID of 2. Does this make sense? Are we cool on this? All right, great, thank you. So now that we have, so we're simulating behavior here. That's all we're doing. We're simulating behavior. And then what we're saying is, shoot. Man, we got to go back and write so much code. Okay, let's do this. I'm going to call this one saved pizza ABC. I'm going to call this one saved pizza XYZ. This is, remember how I said that you don't want to do like white box testing, or you're trying to look for blue wires or anything like that? This is one of those cases where we have to do it, unfortunately. We can talk about this after I do this, though. So, okay. So, oh, XYZ. No, ABC, the other one's XYZ. I don't know why I did that. Okay, so the expected list is going to be the saved version, and this one's going to be the... I'm making things too complicated. I'm going to show you the easy way, and then we'll show you... Then, yeah, I'll show you the easy way, and then maybe we can talk a little bit more about the mocking. So first things first, let's go back to... We're going to go back to Mockito. We're going to do Mockito.when, because now we want to define what this pizza repository is supposed to do. So what this when keyword means, it's saying when somebody calls this method, instead of returning null, I want you to do this. Okay. And I just showed you that when we did s out save, it did something different. So let's go ahead and do this. When mock pizza repository dot save. Okay. And then here, notice that we are saving one pizza and we're saving another pizza. Okay. I'm going to use a keyword here, and I'm going to use any like this. Can I do that? Any. Let me do Mockito.any. Yeah, like that. Okay. So what I'm saying is, it doesn't matter what you give me. I'm going to do the following. I'm going to return something to you, and then I'm going to then return 2 objects. I'm going to return saved pizza. I'm going to return the first one, which is going to be saved pizza XYZ. We gotta fix that. Jeez Louise. So the first thing I'm going to do is I'm going to save XYZ. Let me put it down here because it doesn't know about these variables yet. There we go. And then I'm going to put a comma here because what I'm suggesting is if you call save on me again, I want you to return this next option. So I'm going to then return save pizza ABC like that. Are we good? So far, so good? So now that we've done this, right? When we run this, we're still going to get a fail, but now we're very much closer to getting a good working test here. And here we see a null pointer exception. This pizza repository is null. Can anybody explain to me why they think this pizza repository is null? It's kind of a trick question. It's not a trick question. It's actually legit, but you got to be paying attention. Why is this
Is it because
still
you didn't
null?
create it yet?
What's that?
Or you didn't call for it yet? Or
Yeah,
not?
yeah. You didn't. Well, you didn't say like we're not initializing. Like yeah, we're not initializing it. You never
Right.
initialize it anywhere.
Yeah.
Gotcha. Oh yeah. So the way to do that, and the way to do that in typically the way it's done is you use a constructor. Okay. So what you do is you create a constructor here in your main code called public pizza service and then you're going to pass in a pizza repository, and then inside of here, you then do this.pizza repository is equal to pizza repository. Okay, so we make the constructor. We're putting this guy in here now, which is now being loaded in here, and then this pizza repository is used throughout the production code. The reason we do this is because Spring doesn't require auto-wired at this point anymore. As soon as it sees the constructor and it has a class that has one of your beans, it's going to automatically try to use it. Okay, so you can keep auto-wired here. You can put auto-wired here if you want, or you can just get rid of it, because once it sees the constructor, it automatically knows I'm going to put a pizza repository instance inside of your class for you. Okay, but because we're not using Spring in our test, remember this is pure Java, we need a mechanism to be able to pass this fake pizza repository into our pizza service. And we're doing that right here. So this is called dependency injection. When you hear dependency injection, and when you hear people talk about dependency injection, and you hear people explain dependency injection, it sounds ridiculously complicated, and you get intimidated, and it's very scary. It is not. It is stupid, simple. It is very, very simple. You can sound very smart by saying it. Like, this is very simple. All dependency injection is using a constructor or a setter to populate your dependency with an object. That's it. So I don't have to use a constructor if I don't want to. I can actually do, if I had a setter for my pizza cert for my repository, I can actually do set pizza repository, and then I can also pass in my fake pizza repository that way too. Okay, this is valid. This is also called dependency injection. Okay, so remember, two ways of doing it using vanilla Java. You can use reflection as a third way of doing it, which is what also Spring tries to do. I'll explain that in a little bit, but like, there's only two ways to do it in regular Java. It's constructor and a setter. Okay, and the reason you don't need a constructor here, so if I don't have a constructor here and I have auto-wired, the reason Spring can do this, Spring still follows Java. Spring is, even though Spring is magic, it's still limited by the laws of Java. So the way for it to inject a dependency inside of this class, even though we don't have access to it, it uses a special library called reflection. So reflection is like a meta. Reflection is gives you the functionality to look at the code itself. So I'll give you an example. I don't know if we can. If I do pizza service.class, yeah. So pizza service.getClass gives me the class name, right? So this is kind of like showing you what you can do with reflection. So if I get the class, I can also do get properties. Can I get annotations? Look, I can get the constructors. I can get all the constructors. So if I do pizza service.getClass, I get constructors. I can now access all the constructors for that specific data type, right? It's kind of cool. It's pretty crazy. The only issue with it is it can be slow. So that's why you don't see a lot of people using it. People try not to use it. They only use it for special functionality, but people do not. They frown upon using it because it can get slow, and so typically they try to incorporate it another way. Any questions on this? So if we were taking the test, Spring dependency injection and auto wiring. So Spring auto wiring works by injecting in three ways. One is a constructor, two is a setter, three is reflection. Okay, and then the idea of having a class as a dependency and being able to set it to an object externally from a constructor or a setter, that whole idea, that's called dependency injection. So like, I like to describe it as if you're playing the game of Diablo, you know, in Diablo, you have your main character and he has like his inventory and he has a slot for his hand. You can swap that weapon out with a dagger, an axe, a sword, whatever you want. That's dependency injection. It's giving the external user the ability to swap whatever object that hero is using. And in this case, we are swapping out the object. We're taking our pizza service and we're giving it a fake pizza repository, so it'll use that instead of the real one. Now let me just go back and fix this code. Oh, and do you guys want to? I guess, yeah, I'm sure you want to know the Lombok shortcut for this. So the Lombok shortcut for this is if you go private final pizza repository, and then you just do required args constructor like this, then it will automatically generate a constructor for all of the final fields. So notice how it just creates, like, this thing automatically works. So anytime you want to add a new service, you can do something like final, and let's add another. We already have a pizza service, but I'm going to add another one anyways. It doesn't make any sense, but I just want to give you an example. But notice how Lombok automatically handles it. It creates a constructor automatically with pizza repository and pizza service. And because of the final, you're telling the user, you need an instance of this 100%. Like, you can't get away without setting this up. Like, for this thing to operate functionally, you're going to need some sort of instance for this. And then when we go here to new pizza service, you're going to see here that you have to include a pizza repository and a pizza service. If I really wanted to, I could include null like this, right? And it'll still accept it, and that's fine, depending on your test, right? But ideally, you couldn't put null. Like, ideally, like, you have so much functionality in there that you would have to have some sort of test for it anyways. Or you would have to have some sort of instance, whether it's fake or real, preferably fake, to be able to run the test on that. Any questions on this? Okay, let's go ahead and clean this code up, because we don't need a pizza service here. We don't need this here. We're good to go on this. Am I going too fast, or am I going just right? Any comments, questions?
So you got rid of that auto wired.
Yeah,
tag,
yeah.
'cause you want to go through the Spring Boot?
Yeah. You know what? Let's take this out. This is like super awesome. Like this is very streamlined. But if it's too crazy, let's just put
No,
the
that's
real
fine, yeah.
repository. Yeah, but I prefer readability over streamlined. But if you guys want to do it on yours, feel free to do it. Go for it. And you don't need the auto wired, but I'll still put it on there anyways. Put it on the constructor. Okay, so there is a fun fact. If you have a constructor and a setter, right, in the same class, it can get confused, or if you have multiple constructors, it can get confused. So I think that's where AutoWire can come in handy, because you then specify which constructor you want Spring to execute for you. Does that make sense? Yes, no?
That makes sense.
Yeah, so if you have something like this, right, and then you have something like this, which you're typically not going to see, but if you have something like this, Spring will get confused because it's like, I don't know which one you want me to execute for you. But having the AutoWire here will make
Okay.
sure that this one gets executed, not this one.
Oh.
All right. Okay, so now that we have all of that, oh, when we run this test, it should now pass, I think. And the reason, because now we're passing it, we're giving it the fake repository, and now we can actually execute. And does it work? It works. Cool. So let's look at the code again. Actually, let's refactor this. Jeez Louise. I'm going to take this, and I'm going to cut it, and I'm going to put it at the top here, so that it's in order of 1, 2. And then that way, yeah, let's do this first pizza. Let's rename this again. I'm going to rename this to first pizza. And I'm going to rename this to second pizza so that's just clear, right? Okay, so first pizza, second pizza, I'm going to return first pizza. When I call the mock pizza repository.save method, so when I call the save method the first time, I'm going to return the first pizza. And then when I call the save method the second time, I'm going to return the second pizza. Okay, and then if you look at the code over here, the code returns both of these pizzas that were saved as a list, saved 1 and saved 2. So then I also create a list pizza expected equals list of first pizza, second pizza. By the way, list of is constant. So if you try doing something like this, I don't think it'll let you. So even though it's saying it's letting you, I don't think it'll let you. Let's run it real quick. I could be wrong. Yeah, unsupported operation exception. So whenever you have list of, it's only a read-only list. Just FYI. If you really wanted to edit this list, you would have to do a new array list like that, and then you would put a list of. So you would make a read-only list first, because it's very convenient to make it like this, and then you just wrap it with a new array list, and then now you'll have a updatable list. So when we run this, you should now have 3 lists, or 3 pizzas in the list, and then the table will fail. The test will fail. Yeah. Oh, this is cool. Nice segue. So when you see this, it expected, when you click on this to see the difference, it expected that you get a pizza and then another pizza. So it's saying I expected a pizza of ID 1 and then a pizza with ID 2 and then a pizza with ID 3. So the test is saying I expected these 3 pizzas, but you only had 2 pizzas. ID 1 and ID 2, wherever that is, ID 2. So this is very useful. So assert equals will tell you what is the difference between the both of them. Okay, and the reason we have the difference is because I have to add here. So I'm just going to get rid of that. And yeah, that's pretty much it. That's the test right there. What's wrong with this test? Can you guys tell me what's wrong with this test? Is there a way to cheat this test? Any way to cheat the test? How can you cheat the test? There's always ways to cheat the test, by the way. Well, for the most part.
You mean cheated like with using the source code, or cheating it within the unit test? What do you mean?
Cheat it in here. Like, how do you make this test pass even though it's not working properly?
Oh, I see.
Are you asking about, like, I mean, you could just return the pizzas in a list and not actually save them, but again, we're not
Exactly.
testing that we're saving them, we're just testing that we get through the service method.
Yeah, okay, so there's a fine line right there. The logic of this pizza is that you do save it. You don't care how it's saved, but that you do save it, right? So that could be something that you test. You're not actually checking the database.
On the
yeah, you got to do like a spy or something like that to say, like, did I actually call the save method on this? Okay, so I'll cover that real quick. So Chris is absolutely correct. You can just do this, and oops, you can just do pizza 2 like this, and your test will still pass. You're not, so then this whole mock repository save, like, this is useless at that point, but the test will still pass, right? So to make sure that you're actually saving it, let's go ahead and write another test. It's going to be the same thing. So this is where debatable on whether you want to separate this or not, but let's do this. Should save 2 pizzas. Should have repository save 2 pizzas. So the first pizza here, so this stays the same. First pizza, second pizza. We're saying Mockito, when mock pizza repository calls save of any, so anything, doesn't matter what you pass in here, it's going to first return the first pizza, then it's going to return the second pizza. Okay. Then we are going to expect this. We don't need this anymore because we're already testing it up here. So we can get rid of this, and we can get rid of this assert. Okay. So here's our act. Okay. We generate the pizzas, and we don't even need this list anymore either because we're not actually checking that. We're not actually checking that we got the list because we're already checking it up here. We want to make sure that the repository saved the method. So the way to do that is you use mockito.verify, and then you're going to do mock repository, mock pizza repository, and this is where it gets weird. It's a Mockito thing. Instead of calling the method directly, you have to put the parentheses. You pass in the mock pizza repository in as a parameter, and then outside of it, then you do a dot. And then these are all the methods that are available to you from mock pizza repository. But you're now spying on it, basically. What that means is, by the way, you can't do this with regular services. So if I do pizza service like this, if I try to do this, it's going to break on me because this is a real instance. You can only do this with fake Mockito instances. Okay. So mockito.verify, mock pizza repository, dot, and we want to call save. Now, there's two ways we can do this. The first way we do this is we call save with the actual parameter. So we can do first pizza like this. And then we want to assert that we call the save with the second parameter. So that's the next way of doing it. As soon as we do this, right, we're going to make sure that we actually called this line of code right here. So if you remember, I told you try not to talk about like the red wire hooked up to the blue wire because that's going to hurt your refactoring ability. I'm literally breaking that rule right now with this. Okay. You're only going to see this issue when it comes to repositories because repositories are they connect to databases. So like you don't want to connect to the database. You don't want to have to connect to the internet. You want to be able to run your code locally and quickly. So that's why this is one of the exceptions to that rule. Okay. So Mockito verify mock pizza repository.save first pizza. We're basically saying, did you call this? Did you actually call this? And this parameter has to match exactly. Okay. So when we run this, this should fail because this first pizza, the one that's being passed in, does not match the pizza here that is going in. Why? This ID is null. This guy has 1L. So we run this. Hopefully it fails. And then the way to fix that is just change that to null. Okay. So now that we did this, arguments are different. It wanted pizza repository.save pizza ID 1 small marinara. Actual invocations have different arguments. Pizza repository.save pizza ID null size small marinara Italian thin false XYZ. This is Lombok, by the way. Oh my goodness, if you did not have Lombok, you cannot do this cool stuff like this. Lombok, because of the equals and hash code with the data annotation, it allows you to do value-based comparison. So it's very cool, very straightforward, and it keeps your code very clean and intuitive. You're not thinking about memory addresses. You're thinking, does this object actually match this object? Okay, so the way to get around this, I think we can just pass in null. We could pass null here like this. And if we really wanted to, we can actually take out this too. Because there's no point in store, like, because when we call save and we return the first pizza, second pizza, we don't care about that. We just want to make sure that it's saving it. Oh, no, shoot. Yeah, we can get rid of this. We don't need any logic. There's no logic. We don't care about the list. We're not checking to see if the list was being returned. We care that we actually call mock repository save first pizza, mock repository.save second pizza. And the first pizza and the second pizza, they both have null. So let's go ahead and run this. This passes now. And then so remember we did RED-GREEN-REFACTOR. So we wanted to make sure the test failed. We saw it fail multiple times. That means the test was working. We then figured out a way how to make it pass. So we got it to green, and now we can refactor the code. So to refactor the code, I am changing this pizza and putting it up here because this thing is ridiculously confusing. So I'm going to take that and I'm going to put that here like this. Okay. And how do I know that I screwed it up or not? I don't know. But if I run the test will take care of me. So notice how it just cleans up. Like there's so much less stuff you have to worry about. As soon as you have tests on there, less stress, less cognitive debt, or cognitive load. Like you don't have to remember all this stuff. You just run the test and you're good. Yeah, I changed it. Test pass. I'm good still. I mean, it makes coding fun. Any questions on this? Okay, I think we can wrap it up. Is there any last minute things you guys want to talk about before we end the session?
I had a question. So the guide I watched on mock testing uses an extend with annotation on the entire test class.
Yeah.
Is there any advantage of doing it the way you're doing it versus doing that?
Yes and no. It looks cleaner with the annotations because the way they do it is they do extends with and then they have this at mock like this, right? Is that the way he showed you? Yeah. He has that, and then there's like you then inject it in here. That's fine, but the problem is that we have to discuss the Spring context, so this is out of scope for this class. But like when you run Spring, so when you run Spring Boot, it tries to load up all the beans, right? And only if it's a bean will they try to include it in the context. If you use at mock, you are not actually making a bean. You are just making this fake instance that's living in the test. But if you, as soon as you add at Spring Boot contest or at Spring Boot test, the context is going to try to create a real version. Like the production code is not tied to this right here. So the production code is going to try to create a real pizza repository, and it's going to make a, and then the Java is going to make a fake mock pizza repository here. But then because this thing's auto-wired with the real one, this guy is not going to be used. Does that make sense?
Sorry, I'm not using the Spring Boot test annotation.
No, I know that. I know that. But I'm trying to explain why you don't want to use, or why I don't use @mock. Because if you wanted to create a fake bean for the Spring Boot annotation to be used, you would then use mock bean like this. Okay. So if I want to create a fake annotation that will be used by my Spring context, I would use @mock bean. If I do not, and I'm using regular vanilla Java, then I would use @mock. So if you know that difference, you're good to go. But the majority of developers are not aware of that. And so when you go back and look at enterprise code, you're going to see mock bean. You're going to see all sorts of weird annotations all over the place. And so that's why I prefer this, because it's readable and there's less magic involved, basically. So I mean, you're going to see all sorts. It doesn't really matter, like, yeah. But I find that just the mock and the mock bean is very confusing to people. And they'll have @mock and then they'll ask, how come it's not working in the Spring context? The go-to answer is, oh, you just make a mock bean. Easy. But yeah, I try to avoid that. Okay. All right. Where are we at now? Okay, cool. Any other questions?
Yeah, I had a question.
Yeah, go for it.
So, do you mind pulling up that testing pyramid again?
Yes.
Okay, so you said UI testing is not something we're doing?
Correct. Automated UI testing.
So in the front end, what type of test should we write?
You should write unit tests in the front end. So if you can test the logic of your Java component or your JavaScript component, write those tests. But you don't have to write tests with HTML integrating with the CSS and all of that. If you just keep it to the logic of your the JavaScript itself, I think that's good enough.
So what about like mocking like a login or something like that?
That's a good question. You would use what's called Jasmine, which allows you to create spy objects, and it's very similar to Mockito. And then you would then be able to create like fake services that can then provide the data that you need. So
Okay,
I would
so-
suggest look up like, or you guys are using Mocha, right? Not Jasmine, you're using Mocha?
You
We're
can use
using
VTest to do that. That's what we've been using.
Oh, Vita? Okay, so you can use VTest as well.
Okay. So we want to like include mockings of like login, mockings of like API requests and things
Yeah,
like that.
and when I say mocking, like when I say mocks, I mean like objects that provide dummy data for you.
Right.
Yeah,
Yeah.
that's it. Yeah, you can do that.
Okay. And then like I know like in VTest, for example, you can like check if it renders, like the HTML renders. Like,
Mhm.
do we not need to do that, or should we do that?
You can just run the tests the way they are. You don't have to check for it to render. So in art, like when I'm working with Angular, like there's a create test which just says it loads. So if you want to run that, yeah, that's fine. You can just run that just to make sure. It's more for it's more for the health of the application. It's not for like what makes you feel more comfortable as a tech lead. You know, like making sure that because what you want to do, you want to avoid having stuff break when you're deploying. You're right. So you want to make sure that everything's always working. If something breaks, you want to know immediately that it broke. That's the whole reason why you have it. So having that create type test is fine, but going really deep into making sure that the red and the green are lined up properly, you don't have to do that kind of stuff. If you have special function, like let's say you're making a component and it's a component that its sole job is to like play a sound when you click or something like that, then in that case, well, play a sound's a bad example. It's supposed to like throw fireworks or something like that. Then in that case, I would say, yeah, you might want to test the UI on that because that component, that's the whole purpose of it, right? But if you have like a huge page, you don't have to go in and test every single individual component on there. Does that make sense?
Yeah. So in that sense, like, how would we deal with like a coverage report? Because like, if we don't test everything,
if you would have to configure it to only do the coverage on the JavaScript portion. And if that's not possible, we'll have to figure out a way. You might have to circumvent it and just keep the test coverage on the Spring Boot application. But yeah,
You can ignore file extensions if you want.
Yeah, but the thing is that they're all .view. So is there a way to ignore just the HTML portion of it or the template portion of it?
Oh, well, I mean, what we did is, so there's a suite called View Test Utils, and you can, render the components and test it. It's still like on the unit test level where it's like shallow mounting a component, but it's basically like a unit test for components.
And it's automated?
Yeah, and it's it works along with VTest is a wrapper around Jest, and that's how we do our coverage.
Awesome.
So yeah.
So Chris, you're the one talking to me, right? Or who's
Yep.
Oh, Daniel.
Yeah.
Who's that? Okay, so yes, Daniel, please connect with Chris, and he can show you like his setup.
okay.
But ideally, yes, you want to minimize the number of, because with UI you can just go crazy with tests. You just want to
Right.
focus on the JavaScript and focus on the important UI elements that you think are important. Like for instance, I'll give you an example on one of our applications, because I tell my guys, don't test the UI, you only need to test the logic. In our case, with Angular, logic is put in TS files, and the HTML is an HTML file. So like Chris suggested, you can easily ignore all the other files, and that's how we deal with test coverage, because you only test the TS files. But there have been times when we've implemented like a signature pad or other things that are unique to us that have important functionality. Like, yeah, those you would require tests. Like the dropdown should by default have this value populator or something like that. Like that to me seems very important from a logic perspective, especially since the customer asked for it. So in those cases, yeah, I'll write a test for it. But you have to be you just got to use
one of the nice things about
go for it.
Sorry, I'm lagging a little bit. I have an audio delay. But one of the nice things about the composition API is that you can separate a lot of your logic, into a separate like composable TS file. So I definitely recommend doing that on your components because it's much easier to test all of the logic, separate from the rendering display part of the components.
No, cool. Awesome.
So that way you could just ignore the view file and have all your logic in the TS file.
I'm talking Angular. This is different than Vue, but what Chris is basically saying the same thing. Like there's a way to separate them out.
Yeah, like you could make
I wouldn't ignore the view files, but it does make it easier.
Yep.
So what would be the difference if you're just calling it? Like, wouldn't it be the same amount of testing?
What do you mean by
it's
that?
easier to isolate like the problems.
Oh, just like okay.
So like
Yeah.
imagine you have a bunch of logic that's rendering a list, right, in a component. So you could have all of that inside the component, and then you're testing both, hey, does the logic generate the correct list, and also does the component render the list? But if you extract the composable, then you can test the logic that generates the list separately, and then you can just throw in a sample list into the component as a prop or something, and test to make sure it's rendering the correct number of list items and the correct whatever some elements or whatever.
I would say you would just stop at the list generation, figure out that the list is generated properly, and then you don't even have to write a test for the rendering of that list. So it's like I said, it's up to you on how you want to do it. But for the UI perspective, they're very difficult tests. So that's why we try to minimize them as much as possible.
So we could just write the logic in a separate TS file and then just ignore.
No. When I said TS file, I was talking Angular. Are you using TypeScript with you?
Yeah, we're using TypeScript.
Oh, okay, so there are separate files.
Like that's a feature that we can do with the composition API.
Okay, cool. Yeah. Then, but I haven't done it yet, so that's why I'm kind of confused. But definitely reach out to Chris.
Okay.
And he'll get you set up. Cool. That's awesome. Anybody else have any questions? All right, guys. Well, I hope this was helpful. Oh my gosh. Davi is free. I hope this was helpful, and tomorrow I'll have another office hours, and we will continue talking about testing if you like, or we'll talk about any other topic that you want to discuss. All right, guys. You guys have a great night, and I will see you guys tomorrow.
Don't be a shock.
Ethan, I'm going to kill you, man.